Alright, so for skill 15, we had to choose, let's see, that's 5 values. My A was 12, my B was 5, my C was 13, my H was 4, my K was 8. There's 2 ways you could have done this. You could have essentially just plugged in those values into that equation and graphed it on Desmos. And if you do that, you can graph this equation right here after you plug it all in. And that's one way to do it. Or the other way to do it is to, here, let me see if that'll focus more. There we go. Let's do complete the square. So we can take this base equation right here, and yes, that equation right there, and we can group the y terms together and the x terms together as shown down here, and we can factor out of the y terms we can factor out a 144, and out of the x terms we can factor out a 169. And then from there we can simplify these trinomials into their squares. So essentially this 64 plus 16y plus y squared was simplified into y plus 8 squared, and this 16 minus 8x plus x squared was simplified into x minus 4 squared. And then from there, to simplify this even more, we can transform all the components of this equation into their own roots, and so we'll change 144 into 12 squared, and then we'll change 169 into 13 squared, and then we can change 24,336 into 156 squared, and then from there we can simply divide both sides of this equation by 156 to get the ending equation for the ellipse to be y plus 8 over 13 squared plus x minus 4 over 12 squared equals 1. And then from there we can analyze this equation. It becomes an ellipse. Sorry for this bad drawing. But we're able to determine the vertices, which are 4, 5, and 4, negative 21. The co-vertices are negative 8, and 16, negative 8. We're able to determine the focus, the foci, at 4, negative 3, and 4, negative 13. The centers at 4, negative 8. And then to determine the eccentricity, we can do a squared minus b squared over a. So take a square root of all that. And once we do that, we figure out the eccentricity of this equation is 5 over 13. And from there, the only thing else left to analyze this function are the directrices. And the way that we can do this, we can determine the location of the directrices are, we can simply do this. We can set up the proportion that I did in skill 19, I believe. Yes, skill 19, I believe. And we can do this equation right here. The C over A equals the distance from a point on the graph to a focus from the distance from the point on the graph to the directrix. So we know that the C over A is going to be 5 over 13 because that's what we got up here from the eccentricity, and we can set up the proportion is equal to 8 over y. And once we determine what the y is, we can essentially the point on the graph that I chose to do the point from the point on the graph that I chose to compare the focus, the distance from the focus, and the directrixes was the vertex of the equation. And after I got 20.8, I simply subtracted for this value down here for this directrix. I subtracted the 20.8 from the negative 21 for the y value from the vertex to determine that the directrix was at y equals negative 41.8, and then I added the 20.8 to the directrix up here to determine that the next directrix was going to be at y equals 25.8.